Hi, my name is Angel.
I'm Aaron. I'm Julian.
I'm Mariana, and this is our physics water rocket project.
6 W's we used were the where, when, how, what, who, and why.
So in this case, the where would be at the drainage basin.
The when would be 2 weeks ago, and the how would be with the water rocket and the launch platform.
The what would be the water rocket with compressed air. The who would be class period 6 physics. And the why would be to understand how aerodynamics work.
The sites that we viewed and considered for our water rocket were the handout and a YouTube video, and the rationale we used to select the plan that we ultimately went with was to follow the steps on the handout.
Alright, this is going to be a very quick video to teach you how to make a water rocket that looks something like you see here.
Our independent variable is the amount of water. Our dependent variable is the amount of time the rocket is in the air for. Our hypothesis is that the more water the rocket has, the more would increase the amount of time the rocket is in the air for.
The materials that we used were 2 plastic bottles, Play-Doh, paint, cardboard, and tape. The tools that we used were scissors, paintbrushes, and a launch platform. Weight in the nose cone of the rocket because it's what keeps the rocket balanced. We included fins because it's what provides stability and controls direction. Now the reason why we put tape around the pressure chamber is to keep the walls from expanding and causing a loss of energy. This way the rocket will fly at a higher altitude.
The mass was done by changing the mass on one side until they were both equal.
An issue during launch for us was that the rocket hit the rope on its way up, and the reason why this happened was because the fin or the fins of the rocket became damaged after every attempt. Since the fins are known to be the guidance system for the rocket, it's highly probable that it would deter from its original straight route.
I used Tracker Online to track the time, to track the displacement, to track the velocity, to track acceleration, to track the momentum, and to track the kinetic energy. And I would say our hypothesis is correct. Although our water rocket hit the top of the contraption, it still went pretty high because of the amount of water we put. And the reason the water follows the water rocket is because when the water rocket is launched, the water inside gets expelled out forcefully. And according to Newton's third law of motion, for every action, there's an equal yet opposite reaction. So when the water is expelled, it creates a backwards force, pushing the rocket forward. We learned more about Newton's laws. We also learned about motion, pressure, and aerodynamics. Something I would say that was difficult would be using Tracker Online. It was a bit confusing at first, but I got used to it towards the end. And it was pretty straightforward making our rocket. One thing I would change would be to make our wings straighter and to make them longer. Our wings were pretty short and they were curved, so it would cause our rocket to spin out of control. One thing I would recommend to people who are trying to make water rockets is to use a 2-liter bottle as the rocket's head. We used this size and it remained intact throughout our experiments, allowing us to conduct more efficient and extensive tests.
In the video, as you watch the rocket get launched into the air, you can see with the water spewing out from the bottom. It is actually using Newton's third law of motion, where there is a force of air going in and creating an equal and opposite reaction with the water, propelling the rocket upward.
In conclusion, something that we learned was that what aerodynamics would look like. A difficulty that we encountered was that in the video, the rocket hit the rope on its way up, And if we were to do it again and give advice to anyone trying to replicate our bottled rocket, it would be to use more duct tape to make it denser, which would allow the rocket to go further in height. Another thing that would improve would be that the size of our wings, as they were small, and it's known that long and narrow fins make for the best rockets. This way the rocket's full potential can be reached in an efficient and effective way.
The masking was done by changing the mass on one side until they were both equal.